So we can do it later. Okay, so last time we looked at the topic of generics, and hopefully you guys feel comfortable. In your current assignment, meaning the one that I will give you today, you will not only develop a database solution like we discussed, you'll use the generic concept, for example, to convert a data table to a list of strongly typed objects. So this will give you good experience. The specifications for the assignment, I'll put it on the website. Okay? So later today, please check and you'll get the latest assignment, right? So the next topic that I like to briefly go over is file processing. So reading data from files, writing to files is a fundamental need in any, and we run into it in many scenarios, right? So how do we read data, write data to a file using C#? The answer, it's very similar to Java. If you've done Java, then you'll find it extremely similar. But even if you haven't done, at first it seems a little complicated, but once you get used to it, you will see it's very neatly designed and gives you a great flexibility, not only to be able to read data from a file, but also from a network socket. Okay? So the concept both in Java, both in C# is like this. Okay? If you have any I/O device, okay, for example, a file, okay, we don't try to read the data directly from the file. Okay? So if we wanted to read or write the data from a file, we go through one intermediate level. So we go through what we call a stream. Okay, so first thing is we associate a stream with a file or a network socket or any other input-output medium. Once we have associated the stream, then our code simply reads or writes using the stream object. Okay? The biggest benefit of putting one more level over here is that it makes our code independent of what the actual medium is. So for example, if it's a file, as long as we have a stream associated with it, since our code is only dealing with the stream, it will be, if it is working correctly, then if we change this to, let's say, a network socket, so take a look over here. Since our code was still dealing with the stream, it does not have to change. So it basically makes it flexible so that any medium can be easily read from or written to. Okay? The concept that you need to know now is there are different kinds of stream objects. Okay? There's a text type of stream. Okay, there's a binary stream. So, for example, what if the image, the file is an image file or multimedia file, right? So that would be a binary type of stream that we will need to associate with the file. If it is plain, comma delimited, tab delimited type of text file or a regular text file, then obviously a text stream needs to be associated with it, right? There's another kind called memory stream, where we use the file content and dump it into a memory before further processing with it. So a little bit later I'll show you the memory stream. Anyway, these two are very popular, so today let me at least cover these two. Okay. Now, easy way to remember, because if you go read a book or go to the internet, you will see both in Java, both in C#, there are dozens of different ways to read-write to a file, right? So that it's less confusing, I'll give you my guidelines how you should proceed. So if you can simply remember, if you use the plain stream class without any prefix or postfix, the plain stream class is a binary stream class. Okay. Then if you use a class called stream reader, this will allow you to read data from a text file. Okay, so this is a text type of stream, right? If you use a class called stream writer, it will allow you to write to a file. Okay, so for text type of reading, writing, you will use stream reader, stream writer. For binary type of reading, writer, you will use just the stream object. Okay. Memory stream we'll cover a little bit later. Okay. So our typical procedure for reading, writing to a file goes like this. Number one, create a file object. Okay, so in plain English, associate a stream with it. So again, if it is a text type of file, you will associate a stream reader if you wanted to read from it. If it is a binary type of file, you'll just associate a plain stream with it, right? Okay, once we are associating a stream with it, we will also specify, okay, whether we are reading or writing, or whether the file should already exist if we are writing to it, for example. Okay, for writing, if the file should already exist. So those type of options we can select. Okay. So anyway, the typical. So this is in plain English, right? So now let me show you typical code. So there is a class called file info. Sorry. So we have two classes called file info and directory info in the .NET library, which allow us to explore a directory and pick up a file, and so that we can read or write to it. Okay. So here's a typical code. So you will say, for example, file info, fi equal to new file info, and then in the constructor you will specify the file name. For example, let's say c:"temp", let's say t1.txt. Okay. So notice I'm using 2 backslashes because remember, in a string, if we use 1 backslash, that means the tab, right? So if we literally wanted to say, no, this is not a tab, this is a backslash, then both in Java, C, C++, we use 2 backslashes, okay? In C# you have another option. If before the string, so we could have also said something like this: file info @ So once you put the @ sign, that means treat backslash literally as a backslash. Okay, so if you don't put the @ sign, then anywhere you need 1 backslash, you use 2 backslashes, right? Okay, so anyway, so this is basically creating our file object or file info object. Okay, now we will associate a stream with it. So let's pretend this happens to be some simple file, you know, with some data. Let's say Bill Baker 1234 2.97. So pretend this is the first name, last name, ID, GPA, right? So same way, Sally Simpson 1235, whatever, 3.12, right? And so on. So we wanted to read this file, and our goal was to read each student data and then store it in our database. Okay, so let's pretend this was already typed in a file called t1.txt, right? So we'll start out by file info fi equal to new file info ctem t1.txt. Now we will associate a string with it, so you will say fi.open. Okay, so again, there are many variations of how should we associate a string with it. My suggestion is call the open and specify two parameters over here. Okay, both are enumerations. One of them will let you pick the whether you are reading or writing. One of them will let you pick whether the file should already exist or not. Okay. So once I go to the computer, I'll show you. Based on my memory, it's something like this. I think one of them is called file access. So this is the enumeration .read, comma something file mode. And I may be wrong, so once I go to the computer, I'll double check as I use the IntelliSense. So file mode dot open, and you have other choices like open or create or something like this, right? So we call the open method, and we always give it two parameters. Okay, so if you give it two parameters, then this will return with the stream object. Okay. As I mentioned earlier, if we have the plain stream, what kind of stream it is?
Binary.
Binary stream. Okay. So now if you can remember one more piece of information. The stream classes in the .NET library, okay, use what is called a decorator pattern. So if we have time towards the end of the course, I'll explain what this decorator design pattern is. But if a set of classes implements this pattern, one of the benefits of this pattern is to change one class type to another type, you simply pass an object of one in the constructor. So for example, let's say to convert a stream object to